So now in this video, we're going to look at a voltage boost converter. That's the voltage coming in right now, the alligator clips. As far as the module is concerned, we have 4 volts at the power supply. And so now we're going to turn the light off again, just to read the display a little bit easier. This is the voltage out, 6 volts. That's not enough to light these LEDs. These LEDs are in series, so their voltages are adding up, their forward voltages. The red ones are about 2 volts each for forward voltage. The blue and the green ones about 3 volts each. So since they're end to end, they're anodes towards the resistor, cathodes down towards the blue jumper here, we're going to have somewhere around about 19 volts of forward voltage needed to be met before they start lighting up. We have a little trim pot right here. I'll turn the light on, and so we just take a little screwdriver there, and we can turn it either clockwise like that or counterclockwise. So we're set to 6 volts right now, so we don't want to go clockwise too much. If we go clockwise, it goes down, and we should probably, I'll try to hold those jumpers to steady things, and so we want to stay above 4. That's probably about as low as we want to go. If we turn it counterclockwise this way like that, now you can see it go up. And I'll zoom back a little bit more so we can see the LEDs right there. And try to do this quickly right here. And so we have a wide range of input voltages that we can use and output voltages. I think this goes up to 35 volts out. And so you should probably go no more than about 30 volts in if you're doing 35 volts. But the main thing is you can take a low voltage, having trouble finding the slot, there we go. And now I'll try to turn it quickly. Hopefully I don't slip. It's a little easy to do. Now you can see the LEDs starting to light up. I hope you can see them. Anyways, we'll scoot down a little bit. So we got about 15 volts out. Again, they have a lower forward voltage when very little current is going. But there you can see them getting brighter. Blue and green are just naturally a lot brighter than red right there. And so now we got 19 volts. And it's a 1 kilo ohm resistor limiting current right there. And so we can see the voltage across the 1 kilo ohm resistor to see how much current's going through the LEDs. But we got 22 volts total. So here is the multimeter. We'll set it to measure voltage, and then we'll zoom in a little bit. So don't know how well you can see that. It says 22 in there, and we will zoom in a little bit. We can measure the voltage at the output directly from these screws right there. And you can see it says 21.5 there for whatever reason. So maybe it's not exactly precise what's on the display, but it's good enough. Now we can also check across the rail here too, if we didn't want to go directly to the screws. And look at that voltage, 21.53 again. Now we're going to go across just the resistor. It's 1000 ohm resistor, so each volt across it is 1 milliamp of current. We got 3.65 right there. If we actually want to measure the current, we can plug it. So that's not much current, but those blue and those green LEDs really get bright, even at low current. We can set it to milliamps of current. That says MA. Might be hard to see right there. So we had to open the circuit. We moved the resistor up here, but it's still to the positive supply. And so we'll put the red jumper to the resistor, the black one to the green LED. And once we get a good connection there, you can see we have that current we expected. About 3.65 milliamps of current. So now to get a better idea of what's going on, we're going to look at the power supply for a little bit. So we already established the 4 volts into the module, 22 volts out. Here you can see we got about 70 milliamps right here. Remember, we only have less than 4 milliamps going through the load. That's a huge difference. Of course, it takes some current to power the module. You have some losses and powering the LEDs right there. I think that's the most of it right there, powering those LEDs. Maybe like 20 milliamps or something. But in any case, the vast majority of this 70 milliamps of current, at least a good majority probably, is being converted. So we got a lower voltage and a higher current in than what is going out. So it's taking some of that current, and with the boost circuitry, it's a boost converter. It's converting that current into extra voltage right there. And then you got the losses too. So it's not perfect. if it was perfect, if you have 2 times the voltage coming out as in, you would need twice the current coming in as going out. But it's not perfect. But in any case, this is good enough for this video. There are also buck converters. So the boards look really similar. The difference is they take a higher voltage in and they output a lower voltage, but you get more current out than what you put in, as long as you're not having too much losses along the way. But in any case, we'll take a quick look at this a little closer. To look at the voltage out and in, I just have to press that button once. It bounces back and forth, and we already saw this trim pot changes that voltage out right there. If you hold this down, it gives you a little setting, like 0.123. You can change it, and I don't recommend doing that. I got confused with that. I think that's why instead of this saying 4, now it says 4.08. I think I put it to 4.1 and it's adding, or I think I put it to 0.1 and it's adding 0.1. So unfortunately, these things don't come with instructions. Typically, you got to read other people's reviews and whatnot, but for the most part, they operate kind of similar. So if you understand one, hopefully you can figure out another one without good instructions. But in any case, that's it for this video. Hope you enjoyed. Make sure you check out one of the other ones I'm posting on the screen. If you can, please donate. I have links down below. That helps out the most, but watching videos is greatly appreciated too. So thanks for that. I'll see ya in the next video.